Okay, it's grade 9 maths, guys. We'll start at 9:05. Not 9:05, 7. So we'll start in 5 minutes time. Just waiting for people to join, the relevant people in grade 9 that need to join for the session. So yeah, had 2 sessions in the morning. We had grade 8 earlier on today, all right, and we had grade 10 earlier on today. And the live videos for those respective grades are up on the YouTube channel. The YouTube channel is Maths is a Game. So you can go on there, subscribe, so that when you do get, when I do upload videos, you can actually go ahead and rewatch those videos. So like I said, we did grade 10 earlier on this morning. Grade 10 is always going to be done in the morning at 7 a.m. All right. So sorry, as I was explaining, Koketo, I see you are asking when are you getting the grade 10s ready. Grade 10s already, like I said, we started with the grade 10s earlier on this morning. I had a session with grade 10s this morning, 7 a.m. Yes, every morning, people. Grade 10 is having my early slot, 7 a.m. every single morning. And I know that 7 a.m. for many of you is early, but remember, I also have a schedule. So unfortunately, in between, during the day, it gets a bit busy, so that's why I'm actually having the live sessions in the morning. So grade 10 is always 7 a.m. in the morning. Right now, I'm going to be starting with the grade 9s. That's at 7:05. So in 4 minutes time, we'll start with the session with the grade 9s. But with grade 10, I've already done the session. I've uploaded the live session that I did with the grade 10s on the YouTube channel. So if you want to go and watch the grade 10 session that I did earlier on this morning, it is on the YouTube channel. Yeah, it's on the YouTube channel when Maths is a Game. All right, you can go there and check it out. Also, the grade 8s, I had a session that I did with the grade 8s earlier on this morning on whole numbers. I've also uploaded that video that I did of that live session onto the YouTube channel. So for both grade 8s and grade 10s, the sessions have already been done. Yes, I will be uploading the grade 9 live session as well onto the YouTube channel. That's exactly what I'm going to be doing. So every single time we have a session, I'll go ahead and upload the session onto the YouTube channel. The YouTube channel is exactly the channel's name for TikTok. It's called Maths is a Game. YouTube channel, Maths is a Game. So go and find it. If you want to go to it very easily, you can always go onto the homepage of this TikTok page. Go onto the homepage. Please go to the bio. You can go to the bio, go and click on the YouTube icon. The YouTube icon will send you directly to the YouTube channel. And then you can subscribe so that whenever there's uploads, you can also what do they say, those YouTubers? YouTubers usually say you need to actually ring the bell, notification bell and all of that stuff. You can do that as well. Yes, King Bassist, I am going to do live sessions every day, all right? And so far, the stipulated time, which seems will be very effective for the grade 10s, is 7 a.m. So unfortunately, I will not be changing that time. 7 a.m. Is actually conducive as far as time is concerned. So I'll do the grade 10s at 7 a.m., then I will follow it up with the grade 8s. But the thing is, like I said, I did grade 8 this morning. Grade 8 was done shortly after the grade 10 session was done. So I did the grade 8 session as well. But I've uploaded all those sessions onto the YouTube channel. So the grade 10 session is uploaded. The grade 8 session has been uploaded. Grade 11 will follow at 9 p.m. after I'm done with the grade 9 session, which I'll be doing shortly. So yeah, what time will I finish this session? Most likely I'll finish this session, the grade 9 session, I will finish it at 8 p.m. or slightly before 8 p.m., 8:45. Okay, that's if all things just go smoothly and well. Okay, it's not supposed to be a very long session. We are actually just starting out doing whole numbers for grade 9. So we'll look at that, whole numbers, and just the real number system. We'll look at that today. All right, we're just taking it one step at a time, one incy bincy at a time. We're not doing everything. We're gonna do one thing at a time, one small thing at a time. Let's just hang tight for that. Okay. The question that I'm being asked is, do you do physical sciences grade 10? No, I don't. I don't do physical sciences. Guys, I actually don't do any other grade. Okay. Can I stay even if I'm going next year to grade 9? Yeah, definitely. I mean, this is for grade 9s for next year. Mbali Fuchan. It is definitely for grade 9s. If you're going to grade 9 next year, you should actually be here. These sessions are actually for first term 1 next year. That's the whole point and purpose of having these sessions. It's for you to start the syllabus for next year early, already now, so that when you go to the actual grade, you actually start off on a very good foot. And in actual fact, you'll start off having a great advantage over your fellow friends and peers, who may have not taken the time during the holiday to actually cover the content that is being done in term 1. A very quick story, or let me say a quick experience I want to share with you. My learners at school know very well that I love encouraging them to actually cover the syllabus for term 1 on their own during the holidays. So unlike you guys are having the privilege of having me teach you during the holidays. My learners don't have that privilege. I allow them to actually go over the syllabus on their own. Self-study vibes, you know what I mean? So they have to actually study. I give them the textbook for the next year early, then they have it, then they go through every single page of every chapter of what is going to be covered for next year. That way I cultivate the art of self-study. Then they go over it. When they have questions, they send me messages on WhatsApp. They tell me, sir, I'm stuck in this, I'm stuck in that, I don't understand this line, can you please explain this? Then I'll do that. I'll send a voice note quickly. I'll let them know what it is that they wanted me to explain, and then it unlocks their understanding. Then I ask them to go and do all of the exercises in that particular textbook. So they'll do exercise 1 maybe of a particular topic. They'll do all of the exercises. After they are done, they can just let me know, sir, I'm done. Then what I do is I send them the memo, and then when they get the memo of that particular exercise, I ask them to mark that particular exercise. After they mark it, then they let me know where did they get stuck. If they are stuck somewhere, then I can actually help them out and they can be assisted with whatever they were stuck with. But most of the time, which is beautiful and nice to see, is they actually understand the work on their own. Now, that skill of studying on your own is a very necessary and vital skill for university. If you're going to be a university student, as a grade 10, 11, and 12, you need to cultivate the skill and the art of self-study. Become an independent learner. Do not become so dependent on your teacher so that it seems as if you can do nothing without him or her. So that's something that really helps my learners. And what I've seen is that those who actually do it actively during the holiday, what ends up happening is that without fail, those learners come the following year, they do exceptionally well in mathematics. In actual fact, it is nothing that is very it's not foreign for most of those learners to be getting above 90% for maths consistently throughout the whole year. Okay, so yeah, that's just something to note. I've really encouraged those learners now to actually extend that learning not only to just mathematics but to other subjects as well. Set up a timetable during your holiday. Yes, of course, enjoy your holiday, have that break, but set up some time to do a little bit every day, just a little bit. Even if it's a fraction, just a little bit every day to make a world of a difference. Come next year, when you open the next year, it will not be so, complicated as you think it will be. So I think on that note, let me start off the grade 9 session so that we don't munch up too much of the grade 9's time. Thank you so much for those who are double tapping on the screen, making sure that the live is actually vibrant. Those who are tapping and who are typing and who are asking questions, thank you very much. Those who are participating, those who ask questions when I'm busy with the session, please do make sure that if I am too fast, let me know. If something is not clear, please type there and let me know that, sir, I did not understand that thing. Just make sure that you make me understand what it is that you don't understand so that I can help you out. So all in all, I can think without any further ado, let's start and let's begin. So grade 9 learners, all right, I had sent an annual teaching plan for grade 9s, and that annual teaching plan outlined what you guys will be doing come term 1 next year. All right, so for mathematics term 1 for grade 9s, the very first topic that you guys will be covering is whole numbers. Okay, in other words, you guys will be starting out and getting an understanding once again of the number system. So let's look at the number system. Let's look at the number system. Okay, just hang on for a little bit. I just want to make sure I get my ducks in a row, resources in a row. Just want to check this out quickly. And don't mind the dark screen for now. The dark screen will actually give way to some light. Very shortly, so just be patient with me with that too. Okay, so let's remind each other again. We did say that for grade 9, okay, this is the 2025 annual teaching plan for grade 9 term 1. For grade 9, we did say that the first thing we'll be looking at, let me just remove this thing. We'll be looking at the properties of numbers. In that, what are we going to be doing? We are going to describe the real number system by recognizing, defining, and distinguishing properties of the following numbers. 1. Natural numbers. 2. Whole numbers. 3. Integers. 4. Rational numbers. 5. Irrational numbers. So how are we going to describe the real number system? We are going to describe it by looking at the following numbers, natural numbers. Now maybe just before I even explain what these are, I want someone, okay, so I'm actually going to stop right there for today. I'm not going to go into multiples and factors using prime factorization. I'm actually going to just cover this section here. First and foremost, describing the real number system by recognizing and defining and distinguishing properties of the following. So by understanding the properties of these numbers, we're going to understand what the real number system actually is. All right, so this lesson is going to be very similar to the grade 10 lesson I did earlier on today, okay, and the grade 8 lesson that I did. So look at this. What is, by definition, what are natural numbers? Can someone tell me? In the comment section, someone tell me what are natural numbers. Rara, grade 9 class of 2025 signing in. Or are you saying sing in? Okay, so what are natural numbers, good people? Natural numbers. What is a natural number? Anyone remember what a natural number is? I'm going to wait for someone to comment in the comment section. Natural numbers are numbers from 1 to 9. Sia for Life says. Netsuo says 1. Okay, so Sia for Life, you are on the right track. Okay, And netso, you've just identified a natural number. In fact, Usia for Life identified the first 9 natural numbers. But the thing is, you have not defined what natural numbers are. And what I wanted is for you to define what natural numbers actually are. That's what I want. Okay. So natural numbers, listen to this. Natural numbers they are numbers that start from 1. Natural numbers are numbers that start from 1. So they start from 1, they increase by 1 up until infinity. So Upatient said it nicely. Natural numbers are numbers that we use to count. So when you first learned how to count, I think in grade 1 or grade R, when you started to first count, you started counting and said 1, 2, 3, 4, 5. So natural numbers are numbers that start from 1. Then they increase by 1 all the way up until what? Infinity. Okay? All the way up until infinity. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we can go on forever counting. Would we ever stop? No, we'd never stop. We can go on forever. All right? That's what infinity means. Infinity means there's an endless ongoing of counting, increasing by 1, and you can never ever stop. I mean, you could die counting. All right. If you could start counting now and start counting, you could count and count and count and die counting. All right. Because there's no like biggest natural number, if you will. Okay. So natural numbers are numbers that start from 1. Where they begin at 1. How do they increase? They increase by 1. So the next natural number after 1, or let me say the consecutive number after 1 is 2. The consecutive number after 2 is 3. The word consecutive simply means one after the other. So basically those are natural numbers. Natural numbers are simply numbers that start from 1, increase by 1 all the way to infinity. The word infinity simply means they go on forever and ever and ever and have no end. Those are natural numbers. Okay, I hope we have the natural number definition down. Okay, can we move on to whole numbers? Do we all understand what a natural number is? Natural numbers are numbers that start from 1, increase by 1 up until infinity. Can we move on to the next family of numbers after natural numbers? Are we good to go? Are we good? Okay, all right, I'm going to move on to the next set of numbers. Whole numbers. What are whole numbers? Whole numbers are numbers that start from 0. All right, so natural numbers start at 1, but whole numbers start from 0. They also increase by 1 up until what? Infinity. All right. So a whole number is a number without a fraction or decimal. Umbali Fuchane says a whole number is a number without a fraction or decimal. Okay. All right. Example 0, 1, 2, 3, 4, 5. But I think more specifically, according to this definition, natural whole numbers are numbers that start from 0. They increase by 1. So when you are increasing by 1 from 0, what numbers do you have after 0? You have 1, you have 2, you have 3, you have 4, and all these numbers that I'm identifying are called whole numbers. All right? But what is unique about whole numbers is that whole numbers start from 0 and they increase by 1. Whereas natural numbers, they start from 1 and increase by 1. So natural numbers start from 1, increase by 1. But whole numbers start from 0 and increase by 1. So that's what's different between whole numbers and natural numbers. Okay, so those two definitions are very important. And then I'm going to follow that up with the following set of numbers, which we refer to as integers. Integers. What are integers? So we've already covered what whole numbers are. Whole numbers are numbers that start from 0. We also looked at natural numbers. Natural numbers are numbers that start from 1. Now we are looking at integers. So if we take our whole numbers, and then extend them to include negative numbers, that is the entire family of integers. Integers are simply numbers that are, as it says there, I like what Netso is saying there, positive and negative numbers. But their behavior, the behavior of these numbers is that they increase by 1 and decrease by 1. So for instance, if we say 0, 1, 2, 3, 4, 5, those are whole numbers. If you extend those whole numbers and you include negative numbers, negative 1, negative 2, negative 3, as you are decreasing, negative 1, negative 2, negative 3, you are decreasing by 1. So all of those numbers, negative 1, negative 2, negative 3, negative 4, negative 5, these are including negative numbers, and therefore the family of positive and negative whole numbers we refer to as integers. These are what we refer to as integers. Very, very important. And I hope that's very clear for all of us that integers are positive and negative whole numbers. All right? They increase and decrease by 1. Those are what we refer to as integers. So now we know 3 types of numbers. We know what natural numbers are. Start at 1, increase by 1 up until infinity. We know what whole numbers are. Start from 0, increase by 1 up until infinity. We now also know what integers are. Integers are simply numbers that are positive and negative whole numbers. 0 is there. If we are increasing, we have 1, 2, 3, 4, 5, 6, all the way to infinity. If we are decreasing from 0, we have negative 1, negative 2, negative 3, all the way to negative infinity. So these are basically numbers from negative infinity all the way to positive infinity, and they are increasing and decreasing by 1. So there's something that is shared between natural numbers, whole numbers, and integers. And the thing that is shared is that these numbers increase and decrease by 1. Natural numbers simply start at 1. Whole numbers simply start at 0. Integers include both positive and negative whole numbers. So I hope that is very clear for all of us. All right. Those definitions are very important, grade 9s. As you go on to grade 10, these definitions need to be so clear to you so that it can make life easier as you move along. Right, let's move on now and look at 2 important definitions of 2 important concepts here. The 2 concepts I'm going to talk about are rational numbers and irrational numbers. Rational numbers and irrational numbers. What are rational numbers? And this is what we are going to define at this present moment. All right? So very, very important, and very, very quickly. Just bear with me for a little bit. Just want to grab a pen and a paper here so that we can actually get into the definition of what rational numbers and irrational numbers actually are. Okay. So let's dig in. I want to write this down so that we can sort of like develop it from scratch. Yes, guys, rainbow monkey is a thing. If you didn't know, rainbow monkey is definitely a thing. All right. Okay, let's look at this. Rational numbers. So let's first look at this word, rational. Okay, now this word rational has the word ratio in it. All right. So this word ratio simply means fraction. Okay. Remember, a ratio, for instance, 3:9. This ratio, okay, which is a comparison of two quantities, can be written as 3/9. Okay, so a fraction and a ratio actually mean the same thing. All right. So the word rational actually comes from the word ratio, which means fraction. So now look at the definition as I write it down. What is a rational number? So I'm going to define this. So these are numbers that can be written as a fraction. Rational numbers are numbers that can be written as a fraction, where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0. Okay, so greatest op, you are right. Rational numbers are all numbers that can be written in a ratio. In other words, what does ratio mean? It also means fraction. So these are numbers that can be written as a fraction, where the numerator, remember numerator means the top number, the number above the line. This is the numerator. Where the numerator is a what? Is a integer. Remember, we defined what an integer is. Integers are simply positive and negative whole numbers. Do you remember that? So the numerator must be a integer. And the denominator is a integer. But the denominator cannot be 0. This is the one integer that the denominator can never be. It can't be 0. All right. So this is very important. So example, if we look at the number 7, is this a rational number? Well, we need to ask ourselves the question. Can 7 be written as a fraction where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0? Can we do that? So greatest op says yes. And greatest op, you are exactly correct. 7 can be written as 7/1. Very good. All right, and we can hold it right there. All right, because here what we want to do is we want to move away from this thing of ratio. We want to just focus on the fraction itself, because we've established that ratio means fraction, right? So 7 can be written as 7/1, and definitely if you're writing it as a ratio, it would be 7:1. Okay, so you are spot on, greatest op, but let's be specific. 7 can be written as 7/1. Okay, this is grade 9, but it's applicable to grade 8 and it's applicable to grade 10 if you are a grade 8 and a grade 10 student. This is something that you should know. So at least get grade 10 at least. So 7 is equal to 7/1. All right. So the number is written as a fraction. So therefore, 7 is a rational number. What about 3 over 5? Is this a rational number? Look at the definition again. Numbers that can be written as a fraction, where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0. 3 is an integer. 5 is not 0. 5 is 5. And basically it is also an integer. So 3 over 5 is definitely a rational number. What about, let's look at another example. What about negative 18 over negative 3? Is this a rational number? Negative 18 over negative 3. Is this a rational number? Okay, so most of you are saying yes. On the top, negative 18 is an integer. On the bottom, the denominator, negative 3 is an integer. So therefore, this qualifies as a rational number. Because what did we say a rational number is? Numbers that can be written as a fraction, where the numerator is an integer and the denominator is an integer. But the denominator cannot be 0. So the denominator here is not 0. Let's move on to another example. So we established that is definitely a rational number. What about 0 over 5? Let's look at this fraction. 0 over 5. Is this a rational number? Kaylee says no. Greatest Op says yes. CR for Life says yes. NetSource says yes. Question mark, I don't know who question mark is, but you've got a question mark as your name, TikTok name, says yes. King Basis says yes. Mbali Fuchane says no. Is this section going to be posted on YouTube? Yes, Kaya, it's going to be posted on YouTube. So 0 over 5, people. In the numerator, there's a 0. In the denominator, there's a 5. What is a rational number? Numbers that can be written as a fraction, where the numerator, meaning the top number, is an integer. And the denominator is an integer, but for the denominator cannot be 0. So let's look at this. Is the numerator an integer? Yes. Is the denominator an integer? Yes. Is the denominator 0? No. So therefore 0 over 5 is a rational number, because the 0 is not in the denominator, the 0 is in the numerator. So this is a rational number. Okay. Hope we are together so far. 12 over 0. Is this a rational number? 12 over 0. Stoic, schools are closed, but you know what? Our hearts are open and we want to pass next year. We want a level 7. We don't want to settle for a level 1 or a 2 or a 3 or a 4 or a 5. Though, good it seems that those levels are, but we want a 7, so we are hungry for it. We are hungry for it even now in the festive season. Is 12 over 0, guys, a rational number? No, thank you very much. Greatest Op says it is unidentified. I think the specific word. So 12 over 0, let's look. The definition for rational numbers: numbers that can be written as a fraction, where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0. We have a problem here. The numerator is an integer. The denominator is an integer. So both are integers. But what is the condition that disqualifies this being a rational number? The denominator is 0. We said that the denominator can never be 0. If it is, then it means that this is not a rational number. All right? And I like what someone said here. The denominator cannot be 0. Okay? Because the denominator is 0. Greatest Op, this is what we refer to as an undefined number. It's undefined. We cannot define what 12 divided by 0 is. It's undefined. Okay? So I really love this. This is not an irrational number. This is an undefined number. Okay, it's not irrational. We will look at the definition of what irrational means. But for now, people, let us stick to the definition and our understanding. This is a rational number. Okay, it will not give you a decimal. Okay? It will not give you a decimal. All right. Okay, but we will look at irrational numbers, and we'll look at what irrational numbers are. Now, this is point number one that we need to understand about rational numbers. Rational numbers are numbers that can be written as a fraction, where the numerator is an integer and the denominator is an integer, but the denominator cannot be 0. And this basically is very key and important. Now, let's move on for a little bit. When we look at rational numbers, there are two types of rational decimals that we get. A rational number can be expressed in decimal form. Okay. Yes, Mbali Fuchane, any fraction that has a denominator of 0 is undefined. Very, very key. You've got it down. It does not mean irrational. It means undefined. When we are dividing by 0, a number divided by 0 is undefined. Okay, let's hold it right there. Let me explain something more now. Rational numbers can be expressed in decimal form. There are two types of decimals you can expect to get for rational numbers. The first kind of decimal you will get is what we call a terminating decimal. Anyone know what the word terminate means? Hopefully none of you guys will ever find yourselves being pregnant, and I pray that you guys don't ever fall into that trap. Let us hold our horses until the right time and in the right place under the right circumstances, because terminating a pregnancy is something that people I don't even want to talk about, but it's something that's very, 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 I think for anyone who would have to undergo that, it would be very emotional and very traumatic. The word terminate means to bring something to an end, to stop something. You know, something was obviously happening, but all of a sudden you need to bring it to an end. The movie Terminator is about this machinery that basically just obliterates and kills everything in its wake or in its pathway. The word terminate means to end something. All right. So terminating decimals are simply decimals that come to an end. So in other words, let's look at this. Look at this. 0,4. 0,4. After the comma, the number does not continue, but it comes to an end. It terminates after the comma. So we call this terminating. 4, it ends. 0,4 is what we refer to as a terminating decimal. So 0,4 can be written as 4/10, which can be simplified to become 2/5. Now understand, remember what we said, the definition of a rational number is a number that can be written as a fraction where the numerator and the denominator are integers. This is very true for 4/10. Integer. 0,4 is a terminating decimal. We call this a rational number. Any terminating decimal is a rational number. Let's look at something else. 0,123. 0,123. Do you see this? 0,123. Stop. End. No continuation. End. No continuation. All right. So this is basically what we refer to as a terminating decimal. This terminating decimal can simply be written as 123/1000. If you move the decimal up until you get a whole number, 1, 2, 3 times, that basically says how many zeros after the 1 in the denominator you are going to have 1,000, because we've moved 1, 2, 3 times. We get a whole number, that's 123 in the numerator, over what? 10 to the power, how many times did we move? 1, 2, 3. So it's 123 over 1,000. So terminating decimals are also referred to as rational numbers. All terminating decimals are rational numbers. Are we together? So if ever you see a number in decimal form, you need to check, is it a terminating decimal? Because if it is, then we can simply say that is a rational number. So that is one of the types of decimals we get for rational numbers. Now, the second type of rational number that we get for decimal is a recurring decimal. Recurring decimal. Latin, exactly December. December indeed. The time for us to actually lay a solid foundation for next year. Okay, look at this. Recurring decimals. This is the other type of decimal number that we get, which is also rational. The word recur simply means repeat. Recur means repeat. So in other words, what are we doing here? We are saying after the comma, there is a repetition of maybe one number, or it could be that there is a repetition of two numbers, or there could be a repetition. Okay, let me just 1,723. All right. So in other words, look at this. We usually utilize a dot to signify that a specific number is repeating after the comma. So this is simply just saying this is 1,5, but the 5 repeats infinitely. In other words, it repeats with no end. It repeats forever. But we don't obviously have the space to write all the 5s repeating. So what we do is we simply write down the 5 and then we write a dot on the top to indicate that the 5 is repeating. It is recurring. 1,555555555555555555555555555555555555555555555555555. You know what I mean? Never ending. That's a recurring decimal. It qualifies as a rational number. 1,5. Look at this 5. On top of this 5, we have a line. This also means repeat. Who's repeating? 5 is repeating. Look at this. 1,52. Who is repeating? 52 is a pattern that we're repeating infinitely after the comma. What about this one? 1,723. Look at the line. The line is above 723. Who is repeating? 723. And he's repeating infinitely after the comma. So in other words, they are what we call recurring decimals. Infinite recurring decimals. And I'm going to write this word down. Infinite. In other words, when I say infinite, it means these numbers continue repeating all the way through and they never end. Okay? Right. So please, people, for rational numbers, they can be expressed as decimals, and there are two types of decimals for rational numbers. The first one is terminating. Remember, when you think about terminating, you think about the end, you think about the stop, you think about the end of life, meaning after the comma, the number, whether it be 2 numbers, 3 numbers, basically the number will stop. There'll be a stop after the comma somewhere. Not comma 4 stopped too soon. Here, not comma 1, 2, 3 stopped a little bit later. Not comma 8, 1, 9, 3, 7 stop. Okay, we stopped after the 5th number after the comma. Do you see this? So this is also a rational number. It's terminating. So this is the first type of rational number. We have terminating decimals. The second type of rational number that we have for decimals is an infinite recurring decimal. What does recur mean? It means repeat. Who repeats? The number after the comma. Whether it's a single number that repeats, or it's 2 numbers that repeat, or 3 numbers that repeat, or 4 numbers that repeat. Remember that the dot at the top means repeating. The line above the numbers also means those numbers repeat. That pattern of numbers repeat themselves infinitely. Okay, so I hope that's clear for rational numbers. So if you were to then summarize what rational as a fraction, that one we understand very well. Rational numbers can be written as a fraction. The numerator and the denominator must be integers. The denominator cannot be 0. Then the next thing that we know is that rational numbers can be expressed in decimal form. We have terminating decimals. Numbers after the comma come to an end, whether it be 2 numbers after the fact, 3 numbers after the fact, or 4 numbers after the fact. The fact of the matter is that they come to an end. Then there's also infinite recurring decimals, where there's a repetition of single digits or double digits or 3 digits or whatever the case may be. But there's a repetition and it goes on forever. Okay, so that's very important. Rational numbers. Then let's move on to irrational numbers, which will basically mark the very last part of what I want to cover today. Because remember, according to our guideline, the annual teaching plan, we need to describe the real number system by recognizing and defining and distinguishing the properties of what? Natural numbers. Do we now know and understand what natural numbers are? Definitely. Whole numbers? Yes. Integers? Definitely. Rational numbers? Now we definitely do understand what a rational number is. We understand it according to its fraction. We understand it according to its decimal, either terminating or infinite recurring. Now the last thing we want to look at is irrational numbers. So let's look at what irrational numbers are. So I've written it down here, and this is what irrational numbers are. Irrational numbers are numbers that cannot be written as a fraction with the numerator and denominator as integers. Okay, this is the key important thing here, is that an irrational number is the opposite of what a rational number is. It is numbers that cannot be written as a fraction with numerator and denominator as integers. Okay, I hope that is very clear. Yes, Likona, I will be. Okay, and this will be posted on my YouTube channel after I'm done. I will download the video, post it on the YouTube channel so that people can rewatch it as much and as many times as they want and capture what they did not capture maybe in the session. Okay, but still be here because that will be cool. The name of the YouTube channel is Maths is a Game. Just like the TikTok page, Maths is a Game. I think it's just gone over 300 and something subscribers, so you guys can actually come through and go and fill up those number of subscribers so that we can actually get that channel going. You know, it's only started obviously towards the end of this year, so it's relatively new, but there are videos that have been posted from previous live sessions that I've had, preparing grade 8s for exams, preparing grade 9s for exams during the exam period. Okay, and I've also uploaded the grade 10 and the grade 8 sessions that I held earlier on this morning on the channel already, so they are there to be watched. So irrational numbers, like I said, are what? Are numbers that cannot be written as a fraction with numerator and denominator as integers. Okay, you can also go onto my my bio on this TikTok page. Go and click on the YouTube icon that's there. It will send you directly to the YouTube channel if maybe you are struggling to find the YouTube name. Maths is a Game. Anyways, so let's look at irrational numbers. We have examples here. The square root of 2. Okay, let's Pinky Okopila, what do you want me to repeat? You want me to repeat what irrational numbers are, or are you asking me to repeat about the YouTube channel? What are you asking me to repeat? The definition, okay. So irrational numbers are numbers that cannot be written as a fraction with numerator and denominator as integers. Very important. I repeat, are numbers that cannot be written as a fraction with numerator and denominator as integers. So let's look at this very quickly. Look at this example, the square root of 2. So the square root of 2, all right, if we want to write the square root of 2 as a fraction, we can do that, right? The square root of 2 is basically the square root of 2 over 1. Let's look at whether this can be called a rational number. Remember, we did define what a rational number is. We said a rational number is a number that can be written as a fraction where the numerator is an integer. Guys, the square root of 2, is this an integer? The square root of 2, is this an integer? Square root of 2? It's an integer. Greatest op? Nah. Okay, definitely not, guys. Thank you very much. I would have run away from you guys had you said it's an integer. Square root of 2 is not an integer. What about 1? Is 1 an integer? No. So 1 is an integer on the other hand. 1 is an integer. But what did we say a rational number is? We said a rational number has to have an integer at the top and at the bottom. In this case, we only have an integer at the denominator. Do we have an integer in the numerator? No. So therefore, this qualifies as a what? It qualifies as an irrational number. Numbers that cannot be written as a fraction with the numerator and denominator as integers. They have to both be integers in order for them to qualify as a rational number. But if 1 is not, then it basically means that this is definitely what? Irrational. But there's something else we need to check. The decimals of irrational numbers exhibit the following properties. So look at this. I'm going to type in the square root of 2 in my calculator. Then I'm going to go and press this equal sign. You can see that I have an answer of square root of 2. Then I'm going to come here and change this square root into a decimal. SD, let's press that. Look at what we see. 1, comma, look at the behavior of the numbers. 4, 1, 4, 2, 1, 3, 5, 6, 2. Remember what we said about rational numbers and their decimals. We said that rational numbers, when we did rational numbers, they can either be terminating, but do we see any termination here? No, we don't. Then we said they can also be infinitely recurring. Is there repetition of numbers here, meaning a pattern of repeating numbers? No, there isn't a pattern of repeating numbers. Okay, we have 4, 1, 4, 2, 1, 3, 5, 6, 2. Someone will ask me, 4, there's a 4 there, sir, but look at it, it repeats again there. No, guys, there must be a pattern of repetition. Is there a pattern of repetition here? Definitely not. Can I ask, are you just introducing the topics or are there some activities are going to do with us? Yes, guys, I'm introducing the topics, and obviously there are activities. For all the grades, there are activities that I'm actually going to have you guys do at the end. Okay, so I'm teaching the concept so that you can have a mental understanding of the concept. After you have a mental understanding of the concept, then answering questions should come naturally after that. So I'm going to definitely be doing that after this. Okay, but firstly, I need to make sure that you have the mental understanding of the concept. So 1, 4, 1, 4, 2, 1, 3, 5, 6, 2. 1, we can see that there is no repetition, meaning this is non-recurring. It's not recurring. It's not repeating. 2, we can clearly see that this is also not terminating. It's not stopping. Guys, the only reason why there's 5, 6, 2 and there's no more numbers after the 5, 6, 2 is because my calculator has only that much space. But if I had a calculator that was infinitely big, you guys would see other numbers after 2. You would see a whole family of other numbers with no repetition and no termination, guys. That's what you would see. Okay, so this is a typical example, okay, of a irrational number. Why is it an irrational number? Because it's non-terminating and it's non-recurring. Two things: non-terminating and it's non-recurring. Okay, it's infinitely long. I love that. With no repetition. I love that simplicity. Greatest op. Very good. Spot on. Okay, so non-recurring means no repeating. All right, and then it's non-terminating, meaning there's no stop of those numbers after the comma. They go on, but there's no repetition. Okay, so I love what Greatest Op has said there. It's infinitely long with no repetition. That simply means non-recurring and non-terminating. So non-termination means none means no stop, and then non-recurring means no repeating. No stopping, no repeating. No stopping, no repeating. That's the behavior of irrational numbers. Irrational behavior, even just generally speaking in psychology, when someone is irrational, it means that they are not behaving normally. They are acting in an abnormal fashion. So the numbers after the comma behave in an abnormal fashion because there's no repetition and there's no stop, guys. So this is very, very important. These are the behavior of an irrational number. The decimal behaves in this way. It's non-recurring and non-terminating. So let's go on. Let's look at the other number. So that's square root of 2. Look at the square root of 3. Square root of 3, if we do the same thing, this is grade 9, but also applicable to grade 10. So if you're a grade 10 learner and you are here, this is also applicable to you. It's also applicable to grade 11, okay? Because all of this is content applicable to both, to all these grades. Square root of 3 can be written as square root of 3 over 1. Is this a rational number? Clearly it's not. This is not an integer. If you put the square root of 3 in your calculator, if you want to look at the behavior of the decimal, look at the square root of 3, press SD, look at this. Look at this, guys. Look at this. Look at this. Repetition, no repetition. Termination, no termination. Like I said, the only reason why there's an 8 there and there's nothing after that is because, guys, my calculator space is limited. But if I had an infinitely big calculator, you guys would see other numbers that follow after this 8, and there would be no repetition and no termination. I hope that makes sense. Okay. Okay, the cube root of 4. Okay, cube root of 4 over 1. So same thing. Let's go there. Let's go to our calculator. Shift. And let's go and select this guy here, this yellow guy there, cube root, so that we can go and select there and put in that place of this box the 3. And then let's go inside and put the 4. And then we say equal. And then we say, there we go. You can see the answer. 1,587401052. Repetition? No. So there's no repetition, non-recurring and no stopping, non-terminating. This is irrational number. Here's another thing, pi. Oh wow, pi. At 9 o'clock Lerato is when I'm teaching grade 11. This is pi, guys. Look at this pi. Pi symbol. Pi stands for pi. So the symbol pi is also an irrational number. Okay. In grade 8, you may have been exposed to the 2 rational expressions of pi, which are just simply estimations. You might have learned from your teacher that there's an approximate value that we use for pi, which is 3,14. Or there's a fraction that people tend to use, which is also like a number that's pretty close to pi, which is 22/7. These two numbers are both expressed as approximations, but they are not actually the value of pi. They are numbers that we use to basically say, okay, we can use these in the absence of pi as the actual irrational number, but 3,14 is not exactly pi, and 22/7 is not exactly pi. 3,14, you can see most is a terminating decimal. This is rational. 22/7 is a fraction where both numerator and the denominator are integers, so this is also rational. But pi is not rational, it is irrational. So let's go to the calculator very quickly and just type in this pi so that you guys can see. So this is pi there, and then you can say equal, you can see pi there, and then press SD. Now this is what you see. This is the value, 3,141592654. There is no repetition, and as well as there is no termination. All right, so this is basically an irrational number, very different from 22/7 and 3,14. But we usually use these values as estimations of pi. They are not in and of themselves the actual value of pi. 3,14 is just an estimation rounded off to 2 decimal places, because if you can look at 3,14, if you round it off to 2 decimal places, it's actually 3,14. Okay, and then 22/7 is not pi as well. It is simply an estimation, but it's a rational number. Okay, then last but not least, this is also another number. It's in fraction form, but can we say this is a rational number? The numerator has 1 plus square root of 5. Now let's look at this. Let's just 1 plus square root of 5 over 2. So this is 1 plus square root of 5 over 2. The denominator is an integer. Is this a rational number? Is this rational? Definitely not rational. Okay. If we go and press in the calculator, say equal, then press SD, this is what you see. 1,618033989. Non-recurring and non-terminating. So this is actually a what? It's an irrational number. Okay. So guys, I feel like we need to bring this live to a close and an end. I just want to quickly recap one more time. Yes, Cindy, rational numbers should always make up a fraction, but remember the type of fraction that it should make up is where there's a numerator which is an integer and a denominator that is an integer, and the denominator can never be 0. This is rational. The numerator must be an integer and the denominator must be an integer as well, and the denominator can never be 0. Very, very important. That is what a rational number is. Irrational, on the other hand, is the opposite, and obviously that means there's going to be an absence either in the numerator or the denominator of a integer. Okay, so that's very, 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 and I repeat, very, very important. Okay, so I'm just going to quickly recap. Remember what I said is the first objective that we want to accomplish by doing this topic. Guys, this is term 1, week 1. This is what you should be covering come next year. So I am really helping you guys to actually run ahead of the game so that you guys can have a very solid understanding even now, so that you guys can start doing some exercises and you can get familiar with the content. All right, there's so much more we still yet to do. There's so many days that are left until schools reopen, and guys, we are going somewhere. Okay, so even today, if you feel like, oh, I can feel this, I'm starting to feel it, then please keep that up. Okay, keep that up, keep that going, keep that mental attitude, and please do not get discouraged by certain individuals that are coming into the live. I can understand the shock, right? You can understand the shock of some people coming into the live. They seeing this for the first time. They're like, Aibo, ki December, ki 16, and we are doing maths. Guys, we know what we are doing. We know why we are doing what we're doing, and it's purely because we want to do very well and we want to succeed. Okay, so I'll post this immediately after I'm done with the live session. Okay. On the YouTube channel, Maths is a Game. All right, so here's what we want to recap. We said, firstly, we want to understand what natural numbers are. I explained. What are natural numbers? Numbers that start at 1. They start from 1. They increase by 1 up until infinity. Those are natural numbers. So 1, 2, 3, 4, 5, those early counting numbers we did when we were in grade R, those are natural numbers. They go all the way. We never stop. We just go on. We go on counting. You could die still counting, and you'd never be able to actually get to the pinnacle of numbers. There is no end. You go on forever. But natural numbers, they start at 1. Whole numbers, they don't start at 1. They start from 0. They also increase by 1. Up until what? Infinite. Are we together? 0, 1, 2, 3, those are whole numbers. The minute you say 0, 1, 2, 3, 4, 5, you are speaking about whole numbers. The minute you say 1, 2, 3, 4, 5, you're starting at 1, you're talking about natural numbers. Then we move on to this one, integers. What are integers? Integers are positive and negative whole numbers. The minute you say 0, 1, 2, 3, 4, 5, and you go on forever, you could even go back from 0 and say -1, -2, -3, -4. Those are the entire family of integers. Positive and negative whole numbers, they increase and decrease by 1. Then we've just looked at these two. Rational numbers, we said rational numbers are fractions. Numerator and denominator must be integers, but the denominator can never be what? 0. Then we looked at their decimals. The rational numbers have two types of decimals. The first type, terminating decimals. Second type, recurring decimal, infinite recurring decimal. Those are rational numbers. Then we have irrational numbers. Okay? Irrational numbers, they are basically just that. So how much will you do grade 9 maths introduction? I'm stopping here today, guys. For today, I'm stopping right here. I don't want to go further than this. Okay, next time in our session, we'll continue with the rest. Okay, all right, I'm going to do a bit at a time. Okay, we have an elephant in front of us. We want to eat all of it during festive season. But what we are doing right now is we are grabbing the tail and we are cutting it off and we are dissecting that. And we're having that for starters. We are still going to the bones. We are still going to everything else. We're gonna eat the heart. We're gonna eat everything else. But for now, we are starting off very, very small. Marawai December, kaloku good people. We know what we are gunning for. How much will it be to enroll? It's free. You just need to avail yourself and come during a very busy time, a very holiday relaxed time, which is the festive season. And more than that, please people, all right, being here, that's what gives me the motivation to actually continue with these things. You guys participating, you guys commenting in the comment section, you guys sending me DMs and letting me know how the sessions are treating you and how is it going. Those are all things that are actually motivating me to continue with the session. And when you guys do feel generous to do so, gifts are also welcome as you see fit. Please people, no pressure from anyone, no nothing. All I do want is for you to actually have the benefit of getting this, okay? Are you going to do grade 9 session, 7 p.m. tomorrow? Definitely, King Bassist. Seems like this is our time, okay? Yes, level 7, you can do it indeed, guys. Yo, kill it, level 7 all the way. Nothing less than that, okay? So we have basically come to a beautiful conclusion. And what I want to do now, no, guys, we are in the process. What do you mean? How much will it be to enroll? What is this? Don't people understand that things can be for free? Or like, I don't understand. Is it really something that it's very hard to come by in our day and age? Okay, let's come here. This is a beautiful activity we can look at. Consider the following numbers: 22/7. 3,142 pi 457 minus 457 over 1,256 plus 3,467. That number, the fifth root of negative 32, the cube root of negative 125, square root of negative 9, 4,125. The square root of 1,225 plus 144. 7,1, look at the 1. What does it have on the top there? 54,625625,625. 625, and then a dot to indicate that this continues forever. Right. So first and foremost, I want you guys, from the list of numbers that you see above, to identify a natural number. Okay, we're gonna go through these one by one. Do we still remember what a natural number is, guys, by definition? Because I want us to check, is 22/7 a natural number? Is it? All right. So this is the activity that I'm going to just do with you guys for 15 minutes, and then we'll call it a night. And I will post an activity, sort of like an activity exercise on the TikTok page shortly after I'm done. I will post it as video slides. I did that for the grade 8s and the grade 10s earlier on today. There are 2 videos that I posted that are picture slides of the activity that I expect them to do. So I'm going to do the same with you guys. I'm going to post it shortly after I'm done, after the 15 minutes is done of us going through this activity together, so that we can just be on the same page. So is 22/7 a natural number? Okay, I can see most of you are saying no. Remember, what did we say a natural number is? A natural number is a number that starts at 1, increases by 1 up until infinity. 22/7 does not qualify. Does not qualify at all. You know, remember 22/7, even if we go to the calculator, we can say 22/7. What do we notice? If we press SD, 3,142,857,143. Not a natural number. Remember, natural number 1, 2, 3, 4, 5. So not a natural number. 3,142. Is this a natural number, guys? 3,142. Natural number? Is 3,142 a natural number? God's child, definitely no. I love that. I love that we are saying no very importantly. Ellen, definitely no. Okay. So you guys can see this, eh? All right. Definitely not natural. Not natural at all. Okay. Remember, what are natural numbers? Numbers that start at 1. They start from 1, increase by 1 up until infinity. So both of these don't qualify. What about pi? Is pi a natural number? Okay, CR for life, very quick to say no. Tato, no. Pi is definitely not a natural number. Okay, remember we put it in a calculator and we had found out that it's an irrational number. Okay, someone punched this into their calculator. 457 minus 457 in the numerator gives us what? Gives us a nice, beautiful, big 0. 1,256 plus 3,467. If we add this together, what does it give us in the denominator? It gives us a big number. What is 0 divided by that big number? KB says it gives us 0. Is 0 a natural number? Is 0 a natural number? Is 0 a natural number? No, definitely not. But 0 is a what? Under which 2 family definitions does 0 fall under? Or maybe even more than 2. What is 0? 0 is what kind of number? CR for life says whole number. That's true. It's a whole number. It's also called a what? Besides being a whole number, 0 can also be referred to as a... Besides a whole number, 0 can also be called a integer. Definitely Bonga, very good. Eastern View, very good, integer. And last but not least, Eastern View has also identified the third thing that it is. 0 is a whole number, 0 is an integer, and 0 is also a rational number. Thank you very much, guys. I love it. I love it. Okay, if you can identify the full extent of what a number can be, then you are good. Like, I mean, guys, you should really applaud yourself. If you can identify what a number is, like what family it falls into, you know, then you are good. You are good. I give it to you. Look at this one. Negative 3,467 plus 2,378 in the numerator. How, Tato? No, it's too much. I can't, guys. You can't what, Tato? You can't give up now. What is this? You should notice something about this one. You see, in the numerator, you will get a negative number. But in the denominator, this is the same as negative 2,389 plus 2,389 will give you a number in the denominator that is 0. What is a number divided by 0? It is actually, I love what God's child, undefined. Remember, we said division by 0 means that the number is undefined. Okay, undefined. Okay, so this number is definitely undefined. Okay, it falls under one category, and that is undefined. Okay, let's move on. What about the fifth root of negative 32? This is an odd root for a negative number. All right. Okay, there's a family of numbers that we didn't really touch on. Okay, but yeah, of course, this one will get something. But I was just thinking of this because I was thinking of the square root of negative 9. So let's look at this. The fifth root of negative 32 gives us negative 2. So that number is called a what? What type of number is negative 2? Eastern View says it's an integer. Yes. But what else can we say it is? Negative 2 can also be called a... So it's an integer, definitely. But it can also be referred to as a rational number. Very good, Eastern View. I love this. I love this. So it's a natural number, integer, and a whole number, and a real number. Cindy, negative 32, the fifth root of negative 32 can only be referred to as an integer. That's one. It can also be referred to as a rational number. Those are the only two that we can actually qualify that number being. Okay, so that's very important. It can't be anything else. It's not a natural number, because remember, natural number is a number that starts at 1, increases by 1. Okay, so it can only be an integer, and it can also be a rational number. What about the cube root of negative 125? Okay, calculator will help us very much. Once again, we have an odd negative number, odd root for a negative number, another odd root for a negative number. It gives us a negative 5. Very good. Negative 5 can be referred to as two things. What and what? Negative 5 can be referred to as a, yes, integer, God's child. What else? Bonga, I love that. Negative 5, very good. CR for life, definitely an integer. Natural number, question mark? No. Remember, negative 5. Guys, it's a negative number. Natural numbers start at 1 and increase by 1. Remember, starting at 1, 1, 2, 3, 4, 5. Do you see negative 5 in the mix? If I'm starting at 1 and I'm increasing by 1, there's definitely no negative 5. Okay, so natural numbers start at 1 and increase by 1. Whole numbers start from 0 and increase by 1. Okay, so both natural and whole numbers are positive. The only difference is that whole numbers have 0 in the mix as well. So please, let's not make the mistake of saying it's a natural number, but it's a negative number. Okay. Then last but not least, let's look at this one. What about the square root of negative 9? What kind of number, what do you get from a calculator when you say the square root of negative 9? Square root of negative 9? No, it's not negative 3. Definitely not. No. Eastern View, undefined. No. God's child, undefined. No. I know you guys get Eastern View, imaginary. Yes. Okay. Let's just explain something very quickly here. So division by 0, we've established that is undefined. We are together on that point. But I want to, and it's because you get in your calculator maths error, right? Then whenever you have an even root of a negative number, and this is very purposeful, the root must be even, and the number inside must be a negative number. If you have a even root and there's a negative number inside, all even roots with negative numbers inside are actually referred to are non-real or imaginary. We call these non-real or imaginary numbers. Okay, you can either use non-real if you want, or you can use imaginary. 6 over 0 is undefined. Please, people, this kind of maths error is different from this maths error. This maths error of 6 divided by 0 means undefined. Okay, but whenever you put a even root and there's a negative number inside and you get that maths error in your calculator, it does not mean undefined. It means non-real. It means imaginary number. Okay, and this is very important, and I'm going to stipulate this and I'm going to emphasize this. Okay, the root of -9 is simply this. Okay, this is for the grade 9 syllabus, and we want to stick to that, guys. If you're doing caps, grade 9, grade 10, then basically all we need to just stipulate, we need to write non-real or imaginary. Okay, I'm not going to really look at complex numbers as per other syllabuses, but for now, for any caps student, if you want to contact me on the side and maybe talk about something else that refers to another type of syllabus that you might be doing, please do that. But for the benefit of those who are doing caps, please, guys, we say it's non-real. It's imaginary, okay? Please, that is any even root of any negative number, okay? So the fourth root means even root. Square root, remember, it's just that we don't put the 2, but square root simply means the second root of -4. We say the square root, okay? So any even root of any negative number is always non-real or imaginary. Are we together? But when there's an odd root of a negative number, you will always get an answer there, all right? And it's a matter of just checking your calculator and checking what type of answer do you get. And then according to the decimal or according to the number that you get, you will then define what that type of number is. Okay, guys, thank you very much. That was really fun. Okay, that was really fun. I think I'm going to hold it right there. Juzed Palala, do you do grade 12? Yes, I do grade 12. It's just that I haven't started with grade 12 yet. I'll be starting with grade 12 tomorrow. All right, please just DM me, send me a message on the TikTok, because I have not as of yet sort of figured out what time I would like to actually commence the grade 12 syllabus. For now, I've done grade 8, I've done grade 9, and I've done grade 10. I'll be doing grade 11 shortly at 9 p.m. and then grade 12 definitely tomorrow. I'll find some time. I'll let you guys know on the platform when we are going to have that session. Okay, you're very welcome. To all those who are appreciative of me actually doing this, I am happy to do this. Like I said, my whole heart and intention for doing this is so that at the end of the day, I want to see you guys be happy and succeed. I want you to start feeling that indeed maths is a sweet game that can be played, and in actual fact, the more you play it, the more you get familiar with it, then the easier it becomes. And I mean, distinctions. Guys, that's what we want. We want to just speak the distinction game all the way through. Yes, Sinclair, I will definitely be posting this on the YouTube channel very shortly, all right? Yeah. And SM, unfortunately, I will not repeat this. I will put it on my YouTube channel, because what I do need to do now, I need to stop this live. I need to download the video, post it onto the YouTube channel. But please, I invite you to go onto the YouTube channel and actually rewatch the session on your own, at your own pace, own time. Unfortunately, I do know that it's very different than when you actually are here and you are in the session. And the name of the YouTube channel is simply Maths is a Game. It's just like the TikTok name, Maths is a Game. If you want to make it easier for yourself, you can simply just go onto my homepage of this channel. Go onto the homepage, go to my bio, go to the YouTube icon. You see that YouTube icon? It's just got that white play with the red background. You just click on that. It should send you to the YouTube page, to the direct YouTube page. You subscribe so that whenever I upload videos, you can get the notification early. And yeah, you can watch all the other videos that I've posted before. Like I've done revision exam sessions for grade 8s and 9s, especially during the December holiday. I mean, not December holiday, it was during the November, October exam period. I was helping out a lot with that. My mom, unfortunately, do I have grade 11 maths split lessons? No, I do only pure maths. And the reason why I do pure maths is because, hey, pure maths learners, I found are really struggling. I don't know if you guys saw the stats, but there's actually a statistic that came out. South Africa participates in a yearly session of writing international exams, like our grade 4s, I think our grade 5s, our grade 7s, they participate in it. We were actually ranked as number last in our maths and science results, like internationally, like literally, we were number dead last. So that speaks to a fundamental problem that we seem to be having and a challenge in mathematics. And I want to really sort of like stress that maths doesn't have to be like that. So my whole initiative of doing this, all right, guys, I'm not asking anyone to pay anything, because people are asking me here, like, how much do we have to pay? And I'm saying you don't have to pay dead squat, all right. What I do want us to do here is to actually, like I said, get this maths thing going, okay? I know, it's bad. I know you guys are like shocked and all of that stuff, but this is the reality that we have. So we need to change this narrative of poor maths performance. And it needs to really start in the attitude that learners have even in their schools, you know, and the attitude you guys have towards just mathematics, you know, generally. It doesn't have to be a pain. It doesn't have to be difficult. It doesn't have to be this stress-inducing subject, you know. Yeah, I think we can actually make a difference, and you can turn the tide on that. So I know it's not too many learners that I have here. I mean, I'm looking at like 46 learners that are here, that I can see, that are tangibly here, and I can see that like there's a fraction of those 46 students that are actually literally like actively participating, typing in the comment section, nodding along, probably writing along as well. Okay, I commend you for doing that. Remember that whatever effort and whatever heart that you bring into these sessions, that's as much as you will reap at the end of the day. It will benefit you, not me. And so I'm happy to do this. I'm happy to do it the way that I'm doing it. And hopefully you guys will actually like take advantage of me. Do take advantage of me and take advantage of the fact that I'm here and I'm doing this for you. And you'll be the better for it. So thank you very much. It was amazing. It was epic. It was phenomenal. Until we meet again. So tomorrow I'm having a session again, guys. Same time, same place. Be there or be squared. Grade 9s, I'll take you up on the same time. I think it was 7 p.m. with you guys. I think that will stand as a standing time for us for now. All right, so that I don't disturb you during the day. You guys need to push what you need to push during the day, and then I will definitely come on in the evenings and disturb you a little bit. So please do ask your parents nicely, you know, if you have chores that you need to be doing. Some of you I know are cooking. You are the key rollers in the cooking of the food at home. If you do not cook, the family goes wild and they don't have a good time because you are absent. So just ask them nicely and ask them kindly. Do share with them the initiative and basically how it will help and assist you. I definitely would like to continue helping you guys. Yeah, indeed. So I will be sharing some of the homework that I'd like you to do. I'll post a video just after I'm done with this as well. I'll post it on the page. Grade 10 already has homework that I posted, a video of picture slides that they have to do homework on, and I'll be doing corrections immediately when you start the session tomorrow at 7 a.m. Also, the grade 8s also have homework that I uploaded. So when I start their session, I'll actually go through that homework with them before we start, and then get grade 9s. I'll be posting up some activities for you guys as well. Maybe even this one. I think this one would be good for you. This one. Yeah, I'll take a picture of this and send it to you. You can do this, and then we'll definitely go over it. It's a 19-mark activity, just to sort of like check on, so that you can check on the things that we actually covered today, and if you've got them down. So I'll do that for the grade 9s. The activity will be that. And thank you again. You guys have a good one. Have a good and amazing evening. Till I see you again. And thank you so much. It was phenomenally epic. Please post the notes also. I will do my darndest to do that. Okay, thank you so much, guys. Cheerio, tootles. Goodbye.